So in this class, we will solve some one or two problems, examination problems, VTU Exam Question Paper, July 2022. Of course, this belongs to the first module. Determine the angle alpha for which the moment of 500 Newton force is maximum about the point O. Also find the maximum moment. You can see here, this is the object OBA is the object. He has given the dimensions. This is 100 mm, OB is 100 mm, BA is 150 mm. The angle made by BA with horizontal is 20 degree. A force 500 Newton is acting at A, which makes an angle of alpha with the center line of this BA. You can see here. Now the question here is, we have to find this alpha so that the moment of this 500 Newton force taken above the point O is maximum. That means MO max. MO is maximum. So what is the value of alpha so that the moment of this 500 Newton force taken above the point O is maximum. So after finding alpha, we have to calculate the maximum moment magnitude also. Now for doing this problem, what we will do is, we will resolve this force, 500 Newton force. Let me write the sketch like this. This is 20 degree, this is B, this is O, this is A. So here 500 Newton force is given like this. This is making an angle of alpha with BA extended like this. Now what I do here is, let me resolve this force along this direction as well as perpendicular to this direction. See. So always you can resolve a force into two components which act in the mutually perpendicular directions like this. So since this is alpha, this component will be 500 cos alpha, whereas this component is 500 sin alpha. Now you know the distances. So this distance here is given 100 mm, OB distance, vertical distance, and this distance he has given 150 mm. Now in order to compute the moment, we need moment is defined as magnitude of the force multiplied by the perpendicular distance from the point under consideration. Now the point is O here. Now the moment of this 500 Newton about the point O will be equal to algebraic sum of the moments due to its components about the same point O. We need the perpendicular distances now. Now let me extend this like this. So we need to calculate the perpendicular distance from O to this line of action of this. That means this distance I need to calculate. So once I calculate this distance multiplied by this 500 sin alpha gives the moment about the point O. So now I will draw an ordinate here like this. See, I will drop an ordinate like this. Here, this distance is known now. That is, this is 150 mm. This is given. So if I take this point as C, this point as D, so DC is the same as AB, which is 150 mm, and I need to calculate this distance now. So if you observe the sketch, so here what happens? This angle, so whatever angle is there, this angle will be, so this is, see, this is perpendicular to this. Therefore, when this is 20, this should be 70, and this vertical line is perpendicular to this horizontal line. Therefore, this should be 20. So this plus this is 90, this plus this is 90. So that means this is 20 degree. Now once you know this angle and this hypotenuse, in this triangle this becomes the hypotenuse, this is opposite side. So this value will be 100 into sin 20. 100 into sin 20. That means now the distance OC can be written as OD plus DC, which is 100 sin 20 plus 150. So this is the distance, millimeter. Okay. So OD plus DC is nothing but OC. Now I want the another distance, which is if you extend this line of action, like this. This I will drop a ordinate from O to this line of action. Let me take this as E. So I need to compute this OE because when this OE is multiplied by this force, 500 cos alpha force, that gives the moment about the point O. So perpendicular distance for this 500 cos alpha force is OE from the point O. Now here also, since this is 20 degree, this becomes 20 degree. So therefore, this distance, becomes, you can see from this triangle, from this right angle triangle, you can calculate. Since this becomes the hypotenuse once again, and this is the adjacent angle now. Since it's an adjacent angle, this becomes 100 cos 20. This distance is 100 cos 20. Now, that means the distance OE is 100 cos 20. So now these are the distances now. These are the forces now. Now what I do? Now I will write the expression for the moment about point O. I will call it as MO. So as I already told, MO is nothing but the algebraic sum of the moments due to this and this force. So let me write one by one. First I will write moment due to this 500 cos alpha. This is giving a clockwise moment. You can see that this is giving a clockwise moment about the point O. So I will take the clockwise moment as positive. So therefore the moment due to this force will be 500 cos alpha multiplied by OE. 500 cos alpha into OE. Then moment due to this 500 sin alpha will be, that is also clockwise about the point O. So plus 500 sin alpha is the force multiplied by this distance, that is OC. Now let us substitute now. So MO becomes now 500 cos alpha into OE is 100 cos 20 plus 500 sin alpha into OC is 100 sin 20 plus 150. So this is the moment. Algebraic sum of moments, since both are clockwise, both the values will be positive. Now we can simplify this. So if you simplify this, so you will be getting like this. Let us write the expression now. 500 into 100 is 50,000. 50,000 into this cos 20. Okay, I will multiply that also and I will write. So 50,000 multiplied by cos 20. That is the constant term. 50,000 into cos 20 will be equal to 46,984.6. 46,984.6 into cos alpha is there. Alpha is unknown here. Plus here I have to multiply these two. Of course, this I can simplify. 100 into sin 20. 100 into sin 20 plus 150 into 500. So this comes out to be 92,101. 92,101 sin alpha. So this is the expression for MO. Now we have to calculate the value of alpha so that this MO should be maximum. So MO to be maximum. So for MO to be maximum, the condition is here alpha is the variable. The condition is dMO by d alpha should be equal to 0. So according to calculus, to get the maximum or minimum of a function, the first derivative should be 0. That is the condition. So now what I do here is, I will take the derivative of this and I will equate it to 0. So let me write dMO by d alpha. So we know that derivative of sin alpha is cos alpha and derivative of cos alpha is minus sin alpha. That means this becomes minus 46,984.6 sin alpha. Derivative of cos alpha is sin alpha. Derivative of sin alpha is cos alpha. So plus 92,101 into cos alpha. Okay. This should be equal to 0. The first derivative should be equal to 0. Now if you simplify this, you can get the value of alpha now. So what I do here is, I will take the ratio sin alpha by cos alpha. So if I bring this to that side, it becomes positive. So it becomes 92,101 divided by 46,984.6. So sin alpha by cos alpha is tan alpha. Therefore tan alpha is here. So this divided by 46,984.6. So tan inverse of that, it will give the value 62.97 degree. 62.97 degree. So this is the, of course, alpha is 62.97. So tan alpha is 1.96. It becomes 1.96. Therefore, alpha is tan inverse of that, that is 62.97 degree. So this is the value of alpha for which MO is maximum. So when alpha is equal to 62.97 degree, the moment of this force, centrifugal force about the point O will be maximum. Now let us calculate the value of maximum moment, MO max. So you have to put alpha as 62.97 degree. In the general expression for MO, general expression for MO is this. Okay, so 46,984.6 into cos 62.97 degree plus 92,101 into sin 62.97 degree. So if you simplify this, you get the value of maximum moment at O in Newton millimeter, because moment is force into perpendicular distance. So let us simplify that. For 46,984.6 into cos of 62.97 plus 92,101 into sin 62.97. So the answer is 103,393. 103,393.17. 103,393.17 Newton millimeter. 1,03,393.17 Newton millimeter, and that is clockwise. So this is the value of maximum moment at the point O. So maximum moment due to this centrifugal force at O will be this, and it occurs when the value of alpha, angle made by this 500 Newton force with this axis BA is 62.97 degree. Now another problem we will solve from the same question paper. Second problem I will take up. Second problem states like this. So let me take the second problem. So the problem runs like this. So it is July 2022 paper. One second. It is a concurrent force system problem, second problem. The problem runs like this. Let me write the problem. The sum of two concurrent forces. This is the second problem. The sum of two concurrent forces P and Q is 500 Newton and the resultant is 400 Newton and their resultant is 400 Newton. So figure is not given. If the resultant is perpendicular to P, if the resultant is perpendicular to P, find P, Q and angle between P and Q and the angle between P and Q. So this is the problem given. So there is no figure given, so we have to draw the figure ourselves and then we have to solve the problem. Okay, let me draw the figure now. First, understand the given conditions. P and Q, there are two concurrent forces. That means the lines of action are meeting at a common point. And the sum of the magnitudes of the two forces is given as 500 Newton. So P plus Q is given as 500 Newton. And another condition, the resultant of those two forces is 400 Newton. And the third condition is, there are three conditions here. If the resultant is perpendicular to P, find the value of P, Q and the angle between P and Q. So there are three unknowns here. So PQ are the unknowns and the angle between them, that is the unknown. Now let me draw the diagram first. Understand how to draw the diagram. Let me take the first force P like this. Along the x direction only I will take. Okay? Let us assume. So since nothing is given, along the x axis itself force P is acting and the resultant is making an angle of 90 degrees with the force P. That is the second condition. The resultant is perpendicular to P. See, I am using this condition. This is 90 degrees. This is second condition. This value of resultant force here is given 400 Newton. P is not known. We have to find out. And another force will be there. Naturally, since the resultant R is like this, the third force should act like this. Definitely should act like this, because when you take the resultant of these two, definitely it will be in this direction. So this 2 is also unknown. So what is asked is magnitude of this force P, magnitude of this force Q and the angle between these two. Angle between these two I take it as alpha. Now let me take this angle as theta. So then you know that from the diagram alpha will be 180 minus theta. So once you find out theta, it is very easy to find out alpha. Okay. Now let us write the conditions. Sum of these two forces, sum of the magnitudes of these two forces, P and Q is 500 Newton. So that is the first condition. So P plus Q is equal to 500. He has given this. First condition. We will formulate the equations, then we will solve for the rules. Second condition is resultant is 400 Newton. Resultant R is 400 Newton. Please note that in this problem, resultant is acting along y-axis. See, whenever you know that resultant acts along y-axis, that resultant can be equated to sigma fy. So sigma fy itself is R here. Then what about sigma fx? Sigma fx will be 0. So we have done again these types of problems. If the resultant acts along x-axis, sigma fy will be 0. If the resultant acts along y-axis, sigma fx is 0. Now these are the three conditions we have to make use. So this R means it is 400 Newton. Okay. Now the first condition is P plus Q is equal to 500. Second condition is sigma fy is equal to 400. Third condition is sigma fx is equal to 0. Now using this diagram, we will write down sigma fx and sigma fy. So let us resolve this. Only we have to resolve this force Q now. I will resolve the force Q. The horizontal component of Q will be like this, which is Q cos theta. Vertical component will be like this, which is Q sin theta. You can see here, since the force is acting like this, its components will be in the second quadrant. Q cos theta, because theta is the angle made with the x-axis. Cos component is the horizontal component, sin component is the vertical component. Now, once I resolve that, now let me write down the expressions now. First, I will write sigma fx. Sigma fx is equal to 0. So, this is known. It is given in the problem. Because the resultant is acting along y-axis, sigma fx is 0. Now, let us use the sign convention. Upward positive, downward negative. Forces acting towards right positive, left negative. So, if I take the force acting towards right, P is the force acting towards right and Q cos theta is the force acting towards left. So, the equation now becomes P minus Q cos theta is equal to 0. So, this is the first equation. Now, second equation, sigma Fy is equal to 0. So, this is also Fy is equal to 400. This is also given because resultant acts along y-axis. Sigma F is 400. This is also given. So, sigma Fy, according to this, I will take upward forces positive, downward forces negative. So, upward force means this 400, of course, 400 I have taken the RHS. So, upward force means only this we have to take now, Q sin theta. Resultant is 400 now. So, Q sin theta is the only upward force. This should be equal to 400. So, this is the second equation. And the third equation is this. P plus Q is equal to 500. So, now there are three equations, three unknowns. So, what are the unknowns? P is the unknown, Q is the unknown, theta is the unknown. So, you have three equations and you have three unknowns. You can easily solve them by any method. So, substitution method is the best method we can make use. What I do here is, since this expression contains only Q term, here both P and Q are there. What I will do here is, I will just substitute for P in equation 1. So, you have, now you have this according to from equation 3, sum of the two forces is 500 here given. So, according to this, P will be 500 minus Q. Substitute for P as 500 minus Q in equation 1. In equation 1. So, let us see what happens. So, P is 500 minus Q minus Q cos theta is equal to 0. Now I can write it as 500 is equal to, or I can write Q into 1 plus cos theta is equal to 500. Q into 1 plus cos theta is equal to 500. That's what we get. Now you have this, I will take this equation as equation 4. Now if you compare this 2 and 4, equation 2 and equation 4, you can find out the value of theta by eliminating Q or by just dividing. So what I do here is equation 2 divided by equation 4. So what does it give? Let us see. Q sin theta divided by Q into 1 plus cos theta is equal to 400 divided by 500. 400 divided by 500 is nothing but 0.8. Now, Q you can get cancelled. Sin theta can be written as submultiplying this formula 2 sin theta by 2 cos theta by 2 divided by 1 plus cos theta can be written as 2 cos square theta by 2. So these relationships you should be knowing by trigonometry. Otherwise, it is not possible to solve this equation. It is equal to 0.2. This you have learned in your classes. So once you can simplify this now, 2 gets cancels. 1 cos theta by 2 term gets cancels. So you are left with sin theta by 2 divided by cos theta by 2, which is nothing but tan theta by 2. tan theta by 2 is equal to 0.8, or in other words theta by 2 is tan inverse of 0.8. Tan inverse of 0.8. So I think you will get the value as tan inverse of 0.8 from the calculator. You can calculate. It is 36.66 degree. Sorry, 38.66 degrees. So this is theta by 2. Therefore, theta is 2 times of that. 2 into 38.66, which is into 2, if I take 77.32. So one unknown we got now. So the value of theta now it is 77.32 degrees. So first unknown we got now. Once you get this value, now you can find out P and Q values by using the other two equations. Now since I know the value of theta, I will use this equation 2 to find out Q. Substituting for theta in equation 2. So Q into sin theta is now 77.32 degree is equal to 400, or you can write Q is equal to 400 divided by sin 77.32 degrees. So which is 400 divided by sin 77.32, which is 409.99, or you can take it as 410 Newton. 410 Newton. Okay, so that is the value of Q. So once you get the value of Q, now P can be obtained either by using equation 1 or equation 3. And we know that sum of the two forces, substituting for Q in equation 3, so P will be equal to 500 minus Q, which is 500 minus 410, which is 90 Newton. So like this, we have to find out all the three unknowns. So we got the value of theta, we got the value of Q, we got the value of Q. Now the angle between P and Q is asked that. Angle between P and Q is alpha, according to diagram. So alpha is 180 minus theta, that is 180 minus 77.32 degrees, which is, I can take it as 180 minus 77.32 is 102.68 degrees. So this is the answer. That is the angle between the two forces. Like this, there can be any type of problem like this. So here, very simple concept is, whenever the resultant direction is known, we can use the corresponding equation. We can develop the equations. Only thing is, how many unknowns are there? The number of unknowns should be equal to number of equations or conditions available. Then only we can solve for the unknowns. So this is how we can do the problem. Of course, here this transformation formula, submultiple angle formula, you should be knowing. Then only you can analyze this problem. This is a question paper problem. So in that is July 2022, this problem carries 10 marks in the examination. Okay.